Welcome to qnawire.
This problem has many steps and really tests your mastery of the kinematic equations. The first step is to figure out the velocity of the helicopter once the engine shut off. To do this, we're going to set v naught is equal to 0. A is 5 meters per second while the helicopter's engines are on. The time that the engines are on is 10 seconds, and our unknown is the final velocity. To solve for the final velocity, we're going to use v is equal to v naught plus acceleration times time. Plugging in our values gives a v value of 50 meters per second. Now we also need to know the distance traveled while the engines are on. And so to do that, we set x naught is equal to 0 meters. We're trying to solve for x. Our v naught is 0. We just calculate our final v as 50. Our acceleration is 5, and our time is 10. And so to do this, we can just use the equation x minus x naught is equal to 1/2 v naught plus v times t. When we plug in 10 seconds for t, v naught plus v is 50. So we have 50 times 10, which is 500, divided by 2 gives 250, and then x naught is 0. And so this just gives x is equal to 250 meters. And that's the distance that the helicopter travels while the engine is still on. But then after 10 seconds, the engine turns off and the helicopter still gains some upward distance. And so we need to calculate what that upward distance is. So how much additional height is gained? Well, v naught in this case is going to be 50 after the engine shuts off. V is 0 because we want to go until the helicopter reaches the top of its height, at which point the velocity is 0. Now A is negative 9.8 because after the engine shuts off, the only effect is from gravity. And then x minus x naught is our unknown, the distance traveled in this process. And so we're going to use v squared is equal to v naught squared plus 2 times the acceleration times the change in distance. And so we get 0 is equal to 2500, which is just v naught squared, plus 2 negative 9.8 times x minus x naught, which is our unknown. And then solving this for x minus x naught, I get 127.5 meters. That's the additional height traveled after the engine shut off. So the total height is equal to the sum of 127.5 and 250. So it's 377.5 meters. And that's the answer to part A. Now B has a lot of steps to it, so we'll go through them one at a time. The first step is to find the time until helicopter hits the ground. So find t when helicopter, I'm just going to signify by capital H, hits ground. And so if we say that v naught is 50, so I'm going from the time where the engine shuts off here, so that's 50 meters per second. I'm trying to find the time from this point all the way until the helicopter hits the ground here at this point. And so we don't know the final velocity. That's an unknown. X naught is 250 meters. Our final x is 0. Our acceleration is negative 9.8. And our time is our true unknown. This is also an unknown, but it's not the one that we really want to solve for. We want to find the time. And so we're going to use x minus x naught is equal to v naught t plus 1/2 at squared for this. This gives us a quadratic in time. Plugging in our constants, we get negative 4.9 t squared plus 50 times t plus 250 is equal to 0. And you're going to have to use the quadratic formula to solve this. And so whenever you do that, this problem's already kind of long, so I'm going to avoid doing that out, but you're just going to use the quadratic formula. You're going to get two time values. One of them is going to be negative and one of them is going to be positive. You're going to take the positive time value because the negative time value is unphysical and it doesn't make sense. The positive value is 13.88 seconds. And so that's the time when the helicopter hits the ground. And that's just the first step to doing part B. The second step how high up is Powers after 7 seconds? This is important because after 7 seconds, he activates his parachute. And so if we know how high up Powers is after 7 seconds, it lets us solve for the final quantity that we're interested in. And so in this case, our x naught is 250 meters. Our final x is the unknown of the problem. Our time is 7 seconds. Our acceleration, remember the engines have shut off at this point, so it's negative 9.8. And our initial velocity I took to be 50 meters per second, because I assume that if the helicopter is moving up at 50 meters per second and you step out of it, you're also at that moment going to be moving up at 50 meters per second. So I think a mistake would be to let this be 0. I think it'd be really hard to go 0 meters per second jumping out of something that's moving 50 meters per second. And so to solve for x, I'm going to use x minus x naught is equal to v naught times t plus 1/2 times acceleration times the time squared. After plugging in all my values and simplifying, I get an x value of 359.9 meters. And so if you kind of plot the action here, the helicopter initially moves up, and then after 10 seconds, Powers jumps out and continues to move up. And then after 7 more seconds, he's roughly here, where he activates his parachute. And so now we move on to the third step. We want to know the final velocity of Powers when he activates his parachute. So we want to know his velocity at this moment here. So to do that, we're just going to use v squared is equal to v naught squared plus 2 times the acceleration times x minus x naught. We plug in our knowns here, right? A is negative 9.8. X was found in the previous part. X naught is 250. And v naught squared is found in the previous part as well. And we take the square root and we get 18.6 meters per second. And so that's his velocity right when he activates his parachute. Now we move on to the final step of this problem. And that's figuring out how high Powers is by the time the helicopter hits the ground. Now, when the engine shut off, it took the helicopter 13.88 seconds to hit the ground. And then 7 seconds after the engines broke or turned off, Powers activated his parachute. And so there's still an additional 6.88 seconds that the parachute will be active, but the helicopter will not have hit the ground yet. And so we're going to let that be our t. So our t is 6.88 seconds. Our x naught is 359.9 meters. Our x is our unknown. This is the height where he activates the parachute. Our x is our unknown. Our acceleration is now -2. Negative because it's still downward. And our v naught was calculated just in the previous part as negative 18.6 meters per second. Negative because we're moving down. And so we're going to use x is equal to x naught plus v naught t plus 1/2 AAT squared. We know T, we know A, we know V naught, and we know X naught. And so this is just a calculator plug and chug. And when we do that, we get X is 184.6 meters, which is the final answer to part B.